All right, good morning, everybody. Looks like it's 8 o'clock, and uh, several people are uh, in the waiting room. Let me add them real quick. So they'll be popping into the meeting anytime now. So today we're going to look at the material under week 3 on Zoom. So I'm going to share my screen real quick. So over here, you can see the Canvas modules. So today, what we have is, I put a couple of videos on here that I'm going to pop in and out of in a little bit. Then we have our PowerPoint. We do have quiz 1 that is going to open up today. And you will have until Sunday night at 11:59 p.m. to finish quiz 1. It's 25 questions, true, false, multiple choice. There might be some fill in the blank. Just depends on how the test builds itself. It randomly selects questions from a test bank. Then we have lab 3, and then I have some videos that I'm gonna, when I record, I always put the week's videos there. Okay, so I just wanted to show that really quick, and I'm sure nobody else is trying to get in. And then the other thing I wanted to mention this morning is that today's lab is, I mean, if you look at the number of pages, it's really long, but there are a lot of screenshots. So we're going to install Windows 10 on VMware Workstation, and then we're going to install CentOS on our ESXi server. So I just have screenshots so you can do those correctly. Now, the Windows 10 install, we have to do a little modification to make it work with what we want to do today. So I'll be sure to step through that when we do today's lab. All right. Any questions or comments on anything regarding the course or the semester so far? I know we don't have a lot of opportunity to engage outside of this time. So I want to make sure that you have that opportunity. Anybody? Yeah, Louis, the quiz is open book. Everything in this class is open book, open note, open Google, whatever you want to open. Okay, any other questions? And I have that set to open at 10. Hopefully we'll have some time after 10 to take the lab. If not, it will remain open until Sunday night at 11:59 p.m. So if you don't have time today to take it because of the lab time and the lecture time, be sure to jump into it again sometime after class. Now, you only have one shot at it. So don't open it and then close it and then try to go back into it, because it won't allow you to do that. Once you open it, you need to, finish it. And like I said, there's 25 questions. If you're doing some looking, referencing some of the material, it could take, a couple minutes for a question. So I'd give yourself at least an hour to do it. All right. Well, I'm gonna share my screen again and go into PowerPoint. So, all right. So let me. Oops. All right. Now let me hold on. I'm gonna stop my share and share my other screen. There we go. All right, can you guys see that correctly? Yeah, I guess.
Yes.
Okay, good. Yeah, I lost my chat. There it is. All right, good. And participants window. There's so many things you have to do in Zoom when you're running a meeting to see everything. And when you share one screen, it moves some of the controls on the other screen behind some stuff. So you have to kind of find your way. All right, so today we're going to talk about workstation virtualization. So when we think of workstation virtualization, some of the things we want to do today, some of the objectives for today's lecture is one, learn how to install workstation virtualization on both the Windows and a Linux machine. It's very simple. I mean, we leverage the workstation or desktop virtualization is sometimes referred to throughout the CNET program. In CNET 50, at least when we're face-to-face, there's one lab where we virtualize a lightweight Ubuntu. In CNET 52, we virtualize Linux, Windows, the Mac, and the Windows Server. And then in CNET 56, we use virtualization to build most of our networks. We use a virtual networking program in there called GNS3. And then, of course, in CNET 58, we use virtualization to host all of our servers and our workstations. So it's really an integral part of our program. And you really can't get around the fact that you've got to know and be able to use virtualization. All right. So some of the other things will add virtual machines to the administrative console, use the console for menus, and then perform certain tasks on the virtual machines, which we've done up to this point as well. So one of the things here is that when we virtualize on the desktop, it allows us to run an operating system on our machine, and that operating system is not modified. So for example, if you think back to last week when we installed Server 2019 in our ESXi environment, do you remember a screen or a pop-up in the install that said, hey, we noticed you're installing a virtual machine, let us modify this? No, there is no change. So the same install that we saw last week, even though we were installing it into a virtual environment, will be identical as the install if we were actually on hardware. So if we had a server in front of us, if you had a server at your house and you inserted a USB drive, booted from the USB drive, got into the setup and install routine, the steps, the clicks, the information that you had to apply was identical to that of what we did in our virtual environment. So it's very important that we understand that as far as the end user, so once that server's running, it will function exactly the same as a regular machine on regular hardware. So this concept is known as native virtualization. Now, when we use terminology in technology, a lot of times it's kind of ambiguous or overlapping. And three of these terms, virtualization, emulation, and simulation, they sometimes get used interchangeably. However, they're each very different when it comes to the technology. Now, emulation is where the code actually pretends to be a different environment. So for example, if you've ever done a Nintendo entertainment system, the NES or the Super NES or any of the Nintendo systems, there are emulators that you can download and install, and then you can get the games for those from which are known as ROMs, and you point the emulator to load up the ROM, and it pops up on your screen, and it looks and it pretends to be, Super Mario Brothers or, Super Smash Brothers or whatever game you're playing on your Nintendo emulator. So the emulator run just like the real thing, but they are not. Your computer doesn't automatically or magically become a Nintendo system. It's just software that pretends that it's a Nintendo. Okay. So it's just another program that is running on your operating system. Okay. So there really is no interaction between the emulator and the underlying system. The controls or the CPU, all of that is not using a special version of your CPU to pretend it's their CPU. It's just all done in software. So it's all just coding. Okay. So that's an emulator. How many of you have used an emulator?
I have.
Yeah, a lot of people have. I mean, and if you haven't, if you're looking, if you're thinking about some of the legal aspects of it, if you have a copy of the game, a physical copy of the game, like say you have a Nintendo and you have, Super Mario Brothers, 1, 2, 3, you can legally, if you physically have the cartridge, you can download an emulator and it's not taboo. Okay, so there's some things I'll say about that. Okay, so yeah, and like Jose said in the chat, on your phone, and Robert does Pokemon on his phone, the hardware on our phones is much greater than the hardware that was on those Nintendo systems, especially the early ones. I mean, our phone hardware far exceeds it, so they will run those just fine. Okay, so that's emulation. The next one is virtualization. This is the one that we use, and virtualization acts like the real thing, and it pretends to be real hardware. So unlike the emulator, which pretends to be the entire environment, in virtualization, the hardware, it pretends to be real hardware. So the virtual hardware acts as actual hardware. So the virtualized operating system does not know if it's on bare metal or within the virtualized environment. So what that means is that the system itself, so when we install Windows 10 today in Workstation, it will not know any different that it's not installed on your laptop at home. It will install exactly the same, and it will function exactly the same. And that's a good thing. We don't want to have to modify the functionality, because that will cause some problems. Okay, so the device that allows the hardware to pretend it's real, the real thing, is known as the hypervisor. So in our environment, the hypervisor that we're using, the ESXi is the actual name of VMware's vSphere virtual environments hypervisor. So that's where we've been interacting all this time, is with the hypervisor. Now, and the hypervisor is the link in between your software on your computer that's running the virtual environment and the actual hardware that's on the server. And one of the benefits to this is you can have multiple virtual machines and they can run on the same host and they are completely unaware of their neighbors. So what this allows us to do is to capitalize on some of the infrastructure costs of computing. We can have one computer that can run multiple virtual machines. And within those virtual machines, we can have a wide array of operating systems. So for desktop virtualization and workstation virtualization, that's an amazing characteristic that we as IT professionals and server admins can leverage so that we can support and become familiar with a whole slew of different operating systems. So it allows us to expand our understanding of the IT hardware and software interactions on one machine. So that's virtualization, okay? And then finally is the next term is simulation. So the simulator, probably the best example of a simulator is Microsoft's flight simulator. And the simulation is used to practice in a safe enclosure. So like if you've ever used a flight simulator or, some of the games today are somewhat like simulators, right? Like some of the driving games where you actually feel like you're driving the car. They're not the real, not a real car, but if you were to use Microsoft Flight Simulator, you could learn where all the controls are, where what lever does what system is used to, initiate landing sequence and all those different things in a safe environment so that you don't, have to learn, in the air, because that'd be a very dangerous way to learn such a complicated task as flying, right? Because you only really have one chance to make a mistake and it could be your last chance. So I don't know if any of you have ever walked by in building 28A on the first floor when you probably saw it on your way to the elevator. There's the aeronautics department has a simulator, a flight simulator down there. Now it's much bigger, so it actually looks like the cockpit of an airplane, but it's a way for their students, their aviation students, to learn in a safe enclosure, a safe environment, what a pilot has to know to get, the FAA certified. Okay, so the simulation is an important part for that. All right, now, yeah, Frankie said, can you have an emulator inside a virtual machine? And you can. The only problem is whenever you start doing what's known as nested virtualization or having something inside of something else, it does affect the performance. So now with some of these emulators that are very, very low hardware requirements, you could have a virtual machine that runs a Nintendo emulator and it probably perform just fine. Okay. And then Alan said, would Sandbox be considered simulation or virtualization? It would be more on the virtual side. And, any kind of container environment would fit more into the virtualization side of things. Okay. Now there is a term that you may run into when you start reading a lot about virtualization, and it's just referred to as para-virtualization. Now, para-virtualization is almost the antithesis of native virtualization. And someone define, check your awakeness at the 20 minutes in already. What does native virtualization refer to?
Is it like Hyper-V?
Okay, Frankie said Hyper-V, but even outside of that, Hyper-V is a native virtualization environment. But what does native mean? Is the operating system altered in any way before we install it?
No, it acts like just like a regular operating system on the desktop.
Right, exactly. As Ellen said, it's not changed, it's not modified. It is exactly the same on when we install in a virtual environment as it is on our native or our bare metal hardware install. Okay, as Robert says, the original. Para-virtualization is the opposite of that in that it has to be modified. So there is a difference between the operating system when it's installed or after it's installed than it is. We have to do additional steps than we would on an actual physical machine. So Citrix, which is, if we were to say, look at market share, number one would be VMware. Number two would be Microsoft with Hyper-V. And then number three would be Citrix with their Zen server and their Zen virtualization. And where most of you have probably seen or used Citrix is if you've ever used GoToMeeting or GoToAssist or GoToConference, any of those software versions, that's all running on the back end with Citrix. So that's a good example of that. Now, last week I asked you a question in lab that said, what does VMware tools do for you? And almost everybody, saw that little box on right on the home screen of the virtual machine, the settings in ESXi, that right there, it said this allows for better performance, better optimization, better look and feel. So when we install the guest tools, or the VMware tools as they're called in VMware, that is a form of para-virtualization. So even though ESXi does not require a modification, if we want better drag and drop support between our host and our virtual, or if we want better resolution or better screen sizes, or if we wanted to automatically synchronize the hardware clock in the virtual machine to the system, the host machine, then we would install the guest tools. So once you install the guest tools, that is a form of para-virtualization. Okay, so there's that. So before we get into the history of this, I want to come back to a video here. So here, this is on week 3. It's called Quick Video. I'm gonna open this in a new window, and hopefully you can see this. Hold on. At the volume are low, and then. All right, can everybody see that video? And okay, good. So this is from a company called CBT Nuggets, and the CBT stands for computer-based training. And this is a company that has created a whole bunch. I mean, they have a big fat library of products that you can subscribe to, and you can either subscribe to it on a yearly basis and where you have access to everything, or you can just purchase access to a particular area. And this is their, what is virtualization? And I like this because I think they stole my idea of Inception. Remember I mentioned Inception a couple of weeks ago? So let's watch this. It's only a couple minutes.
I was about 10 years old when I had this crazy dream where I was watching from this balcony as my father dueled Dracula with lightsabers. It was crazy. It was an epic battle, but I couldn't tell you who won because I woke up before the end. And I went upstairs and I saw my parents and I wanted to tell them about the dream. They were there doing some kind of cooking, which was kind of odd for the middle of the night. And I started to tell them about this dream when suddenly their heads rotated 180 degrees. And they said in eerie unison, "You're still dreaming." Saha, I'm Jacob Moran, and I told you about my crazy dream because as we start to explore and introduce this idea of virtualization, I really want you to have that inception idea that there is a world within a world, and that's going to be what drives our ability to create abstraction. My friend, that abstraction is what drives the core element of what we're talking about right now, which is server and desktop virtualization. Back in the day, what we have, a piece of hardware. What do you have to do with that hardware? You had to install an operating system. What did you install in that operating system? Applications. And what did you do after the applications? You had to do customizations. And that's a big, long, labor-inducing process that costs a lot of money. So rather than going down that path, the world of virtualization says this: let's slip in a little something right here called a hypervisor, because that hypervisor is software that is designed to launch virtual machines. What's a virtual machine? Well, the key word there is machine. It's designed to emulate the hardware, but do so in the form of a file. It's a file the hypervisor will launch and execute and follow the rules of, rules that define hardware. So it's a box within the box. Now, once that box boots up with its virtual memory, its virtual CPU, its virtual hard drive, which by the way is usually another file, then we can come in and apply all of those other elements, the operating system that needs to be put on that hardware, the applications and the customizations. We're doing that all now to the virtual machine instead of a bare metal install on top of the hardware. And the advantage of that is that because of the way the virtual machines work, we could execute that same process multiple times and run 2 or 3 or 5 or 10 virtual machines all on the same host simultaneously. So now we're able to save money. In this example, we see we've got a 3-to-1 ratio. That's one piece of hardware instead of 3 for the initial outlay of the infrastructure. And we're saving money indirectly too, because we're only having to power 1 physical machine instead of 3. We're only having to cool 1 machine instead of 3. And because this is software defined, we're going to be able to save in time, not just the initial time that it takes to, request hardware and actually get it delivered to us, but because we're dealing with elements that are files, we can start doing things like templates and automation. The world of DevOps really opens up to us. And all of this abstraction goes through the roof and continues to be even more powerful when we start looking at deploying these very same technologies in a cloud infrastructure. So cloud technologies are not virtualization. Virtualization is one of the building blocks that allows for abstraction, which is so convenient for a multi-tenant cloud-based environment where we want to be able to easily automate the process of rolling out whatever the customer needs on demand. Are you picking up what I'm putting down? Virtualization is some great technology. The power of abstraction frees us from the shackles, from the bondage to our physical hardware, and allows us to do things that we otherwise could not even dream of doing. I hope this has been informative for you, and I'd like to thank you for viewing.
All right, so that's that video. So where did all this start? So in 1998, so in terms of, history books or, current events or anything like that, 1998 would not seem like that long ago. I mean, although probably a good chunk of our class was born after 1998, right? With it being 2021 now, if you're born in 1998, you'd be what, 23 years old? So it's not that long ago from a history standpoint, but in computer terms, it's been a little while ago. So in 1998, VMware, and they're the main players in I mean, they're the #1 company in virtualization because they created it. And they were able to figure out how to virtualize the x86 or the 32-bit of the 32-bit processor and operating system, and create the market for virtualization. So at the time, that was a really big achievement. So if we look at the timeline here, so in 98, VMware was founded, and then it went through a couple years later, they had Workstation, a couple years later, Server, then they started with ESX Server, 1 million VMware users, and then they got into vMotion, and then all this things in with their current dominating system known as vSphere, which we're going to talk about the vSphere product next week. But you can see they've developed all of this all the way through. And then they show Zen up here. They started off much later. And then the Hyper-V came way after the fact, not until like 2008 with Server 2008. So as desktop and server processing capacity has consistently increased, and that's, you're probably familiar with the term Moore's law, right? That basically says the number of transistors or the processing power in a computer will double approximately every 18 months. And that means that as our processors gotten more and more powerful, more and more capable, the ability to use virtualization has become easier and less labor intensive on the host machine. So this enables us to do all kinds of powerful virtual environments that can simplify software development and testing, enable server consolidation, and enhance data center agility and business continuity. Now, the agility, that's just like, you know, when we think of our football drills, right? If you've ever been on a football team where you have to run through the ropes, right, with your feet, and that's just to get your agility better. You know, basketball, you dribble through the cones and stuff like that. Those are all agility-based exercises or drills. And then business continuity means that no matter what, our business can continue. So even if there's a natural disaster or a power outage or anything like that, man-made, that our business can continue going. All right. So this technology allows for fully encapsulated portable virtual machines to possess features that are not possible on real hardware. So for example, extremely fault-tolerant configurations on virtual infrastructures with 24/7, 365, no downtime for backup or hardware maintenance. So imagine trying to do this, no downtime in a physical environment. That would be nearly impossible because there will be downtime. I mean, there's just things that we have to do. We have to install updates. We have to, you know, replace hard drives. We have to, you know, deal with blackouts or rolling brownouts or, you know, any of those kinds of things. Those happen. But in a virtual environment, we can look at this and say, we can build our environment. Now, this means we're going to pay for it, but we could do it if our boss has said, this project, this system has to be available every single second of every single day for every single year coming forward. Then we would say, okay, we need to virtualize this and then set up our virtual environment to have all of these rollover and fault tolerance and business continuity conceptions in there to do it. Okay. So the key to this, the building the thing that once it was unlocked, it opened the door to all kinds of possibilities is with the CPU virtualization. Now, if you're really into CPU design or how the CPU is engineered, there's a major called computer science and engineering that looks at that from a design and engineering standpoint. For us as technicians, we're only going to kind of look at it as a device and talk about some of the functions. So the CPU, the x86, the 32-bit, the 16-bit, the 8-bit, right, that it evolved from, offers what are known as levels of privilege, where certain things can only function or operate within that level. So, and in CPU architecture, those are known as rings, with ring 0 being at the very bottom and then ring 3 being at the top. So in between those rings, certain things can happen. Now, for those of you that have taken the CNET's operating system class, we talk about the difference between kernel mode and the kernel mode, and then what's the other one? Anybody remember? No. Well, the two modes that allow us in the kernel mode is closest to the hardware, and then the system mode is closer to the software. So only certain things can function in certain modes. Now that's in the operating system kernel. The hardware at the CPU, they have this ring 0, ring 1, ring 2, and ring 3. So what this allows is for things to have what are known as levels of privilege. So at ring 0, it is directly connected. So that's the area of the system that can communicate directly to the hardware. So here we have the hardware, and then at ring 0, we have these kernel. This would be the kernel mode of the operating system that can communicate with the hardware. So this is the part of when we talk about device drivers in our operating system, they function in kernel mode because they can communicate directly to the hardware. All right. Then we have ring 1, ring 2, and then at the top, we have the user with their applications. So for example, if I have Microsoft Word installed in Windows 10, and I'm the user, I open Word and I tell a document to print, that application, Windows or Microsoft Word, is going to communicate to the USB port on my computer or my network card on my computer to send that document in the code that the printer can understand. Normally it's going to be the PCL, the printer control language, or PostScript, and with the language that it's going to send to the printer. And then it's going to be filtered through the operating system to use the correct driver for the printer. So if I have an HP, 6500N printer, my Word doesn't care what printer. I mean, it doesn't have anything to do with the printer. It just says, hey, operating system, send this data to the printer. And then the operating system says, okay, I'm going to communicate with the port, send it, and away it goes. Okay. So that's how a typical CPU functions. So when we virtualize this, it allows the virtualization to get underneath ring 0, which is the most privileged ring. So now the virtualization layer sits on top of the hardware, and then the operating system is above the virtualization environment. So this was a major change and a major challenge for VMware to figure out how to do that prior to 1998. So VMware solved this problem by developing their virtual machine manager. So their virtual machine manager is their administrative console, okay? And this performs binary translation techniques that allow the virtual machine manager to run in ring 0 while everybody else gets bumped up a ring, okay? So now the operating system isn't at ring 0, it's at ring 1, okay? So here's a picture of that. So now with the binary translation of the operating system request, right, it's been virtualized, the guest operating system will now communicate directly with the VMM, and then it will communicate with the hardware. Now the user app is still going to go through that process. Now let's say I have a Windows 10 as my guest operating system. So say my host machine hardware and software is, say, ESXi, and then I create a Windows 10 VM. The VMM, the virtual machine manager, sits at ring 0. The guest is here, and then if I have Word in my virtual, it is going to function the same, but now it has to go through multiple layers. And whenever we have to go through layers, it takes a little bit of time, okay? But this concept of the binary translation, it really allows our, it opened up the ability to virtualize just about anything. So the combination of binary translation and direct execution provides full virtualization as the guest OS is fully abstracted from the underlying hardware by the virtualization layer. And this is known as full virtualization. Now, the guest OS is not aware it's being virtualized and therefore requires no modification. So, and again, if we have to modify it, that's known as para-virtualization. If we don't, that's full or native virtualization. All right, any questions on that concept? I mean, we're kind of using it so frequently that sometimes we can lose sight of the fact that this is what's actually happening, right? Any comments? No? All right, good. So the other benefit that these virtuals allow us to incorporate is that there is isolation and security between the virtual machines. And it simplifies our machine migration and the portability of the operating system to run in our virtual environments. So there's a concept known as the virtual desktop infrastructure, or VDI, which is really popular today, especially with remote workers, where businesses are able to take machines, either import them or convert them from physical to virtual, and then makes the virtual available through the cloud and remote desktop capabilities so that workers can log in remotely to their actual desktop, and it allows them to run in a virtual environment. Now, this is similar to a degree to what we're doing with the Apache Guacamole. The Apache Guacamole server is what's known as a remote desktop broker. So it just transfers the connection from one to the other. The difference is in VDI, you're connecting to a virtual machine. In our environment, we're connecting to an actual physical machine using remote desktop technology. Now, the benefit of VDI is all those machines can be on one server or several servers. And then they start getting the benefits of the cost savings for the hardware, the cost savings for the electricity, and cost savings for cooling, and the simplification of managing it. Okay, so this is one of the key benefits. Now, we mentioned para-virtualization earlier, and that requires modification. And the root word para is from the Greek origin, and it means alongside or beside. So one of the disadvantages of para-virtualization is that the performance is going to be minimized or a little less than if it was fully virtualized. So if we're looking for ultimate performance, then we would try to avoid anything that does any kind of para-virtualization. All right. So with our para-virtualization, there's another layer that our system has to work through. And whenever we have to go through more layers, the slower the process becomes. Okay. Now, VMware has used certain aspects of para-virtualization. Their tools allow that. And the VMware tools provide a backdoor to the VMM hypervisor used for services such as time, synchronization, the logging, and then the ability to shut down the guest with one button. They do modify the guest operating system, but they do not modify the kernel. So the kernel, again, is part of the operating system. Now, one of the things that was required in order, now with 32-bit or x86 platforms, up to this point, everything VMware had done worked perfectly. They were able to virtualize, any operating system as long as it was no more than 32-bit. So when processor design went to 64 bits, so 32 bits and 64 bits is just referring to how many single bits of information, how many zeros and ones can the processor compute or work with at one time, specifically with the address bus between the processor and the memory. So that link is normally the width of our processor's size. So if it's 32 bits, that means 32 bits can be accessed at one time from memory. So that's 2 to the 32nd power, which is about 4 gigabits, 4,096 megabits or million bits. Okay. And with 64 bits, that means there's 64 single bits that can be accessed between the processor and the memory. So that means it's like 16 exabytes. So it goes kilo, mega, giga, tera, and then peta, and then exabytes. Okay, so it's up there in the size, very, very large. So once the processors changed to 64-bit, with VMware or any of these virtual environments, if you had a operating system above that, you couldn't virtualize it. It would not work. So Intel and AMD, which are the two main leaders in the processor manufacturing, they had to modify their code base of their processors. So if we think of hardware and software, the processor actually is both, right? It is hardware in that there's transistors and logic chips and storage areas, buffers and caches and stuff like that. So it's hardware, but it also has code that allows it to run. So that code is software. And Intel had to modify that code to allow virtualization of 64-bit applications or 64-bit operating systems to run on a 64-bit processor. So this, when AMD and Intel created this, AMD calls it VT-X and Intel calls it AMD-V. And it's just the code and the function that Intel and AMD put into their chips. And this is referred to as HAV, or hardware assisted virtualization. So HAV allows the VMM to run in a new root mode, which is under ring 0. So with this hardware assisted virtualization, it's gotten even closer to the hardware, which means better performance, right? The closer we can get to the hardware without layers, the faster, the better the performance is going to be. So this removed the ability or the need for complex binary translation or any other paravirtualization. So now the VMM is under ring 0. So now everything, the VMM is closest to the hardware, which eliminates the need for any kind of binary translation. Okay, so this improves performance. Now, this concept is now very, very common in processor design, right? Most CPUs are created to take advantage of hardware assisted virtualization. Now, to turn it on, a lot of systems, by default, it's turned off. So you may have to, if you try to install, say, Hyper-V, Windows 10 Hyper-V on your machine, and you go to run it, the installer may say, this is not supported because hardware assisted virtualization is not enabled. And if that's the case, then what you need to do is go into your BIOS or your UEFI and turn it on. So you have to consult your motherboard manufacturer to find where it is. Most of the time, it's under either security options or integrated peripherals, and you can find it somewhere in the ESX, the UEFI or the BIOS. With the newer, it's going to all be in UEFI. All right. Any questions on any of this information so far? Nope. Okay, good. So I'm gonna pause the recording and give everybody a chance to take a short break. So I'm gonna pause it. So the key to all of this virtualization was unlocking the processor. Once the CPU was encumbered with having to do extra functions just to do the virtual processors, it greatly improved the performance and the capability of virtualization. So that led to where we can now hold on, I think I shared the wrong thing here. Yeah, there we go. So now I'm back in business here. So that allowed it to move on from the processor to some of the other capabilities. And the next critical component, so the main functions of the processor once those were kind of ironed out, the next area that we could concentrate on was how do we deal with memory? Now, when we think of the CPU and of memory, it's hard, it's not impossible, but it's very difficult to share memory usage between different virtual machines. So if I have Windows Server parent and CentOS 8 parent and Windows 10 parent, though they cannot share memory space because the operating system is going to access that memory and they're going to lock it. They're going to make it so nobody else can read or write to prevent it from being corrupted for security reasons. Okay, so once the CPU is virtualized, the memory came next. Now the physical system memory is shared and dynamically allocated to the virtual machines. So they're going to use or utilize this memory very similar to the virtual memory support provided by modern operating systems. So this is referring to our page file.sys or our virtual memory in our operating systems, which now they look first information when an operating system needs information, it will look first in the processor in the registers, then it will look in the L1, L2, and L3 cache, then it will look in the system memory, the RAM, and if it's not there, it will look in the hard drive, which is the next layer for our virtual memory on our operating system. So the way our VMs work is similar to that. They'll look in the virtual processor, then they'll look in the virtual memory, and then they'll look in the system hard drive for the virtual memory there. Okay. Now, all modern x86 CPUs include a memory management unit or an MMU that can do a translation look aside buffer or the TLB. Now, to run multiple virtual machines on a single system, another level of virtualization, memory virtualization is required, and that's where the memory management unit is virtualized. So it's almost like whatever we did in our physical machine, we're doing in the virtual machine's hypervisor is doing these same steps. Okay, so here's a graphic where it shows my physical machine memory is this red, and then my VMs will have to take parts of this memory for their virtual machines. Okay, now these VMs, so the sum of the memory between these VMs cannot be greater than or equal to the system memory. So when we create our VMs, now here's the thing that we are going to have to juggle a little bit or coordinate in our systems that we develop down the road is to install them and get them going. The more memory, the better. So we may start off with, say 4 gigs of RAM in Windows 10 and 4 gigs or even 8 gigs in our server VMs. Well, it's not going to take too long, 2 or 3 virtual machines, and we're going to be up against the threshold of the maximum physical memory or machine memory that we have available, which in our servers is 32 gigs. So when we start running, 5, 6, 7, 8 different virtual machines, we're going to have to really pare those down to the minimum amount of memory. And then we know what happens to an operating system if it doesn't have a lot of memory, is it really starts slowing down. So performance and availability are sometimes mutually exclusive. So we may be able to get a lot of VMs set up and running, but the performance may be kind of painful. So we always want to keep that in mind as well. Okay. So another thing that we can virtualize is the input output and our devices. Now, I will tell you that the difference between VMware Workstation and Oracle's VirtualBox and, you know, Apple's the Macintosh Parallels and some of these different platforms, the difference between them really doesn't always come down to performance. It comes down to how do they work well with devices. So sometimes our virtual machine, we don't need to use any external input output or any external device configuration. So we're not going to care, you know, especially on a server. I mean, most of our servers, we don't even care about the graphics capabilities, right? Minimal graphics is fine because we're either going to remote in, which is already degraded graphics, or we're going to shell in where all we're going to use is a command line. So the different virtuals, we may have different needs for it. Now, if we were in a business, say we're in a manufacturing or an industrial design environment where our workers are maybe building architects or building designers, and they're doing a lot of CAD work with the computer automated drafting, well, then that becomes a lot different, right? Those systems would probably need a strong graphics virtualization for the device of the graphics card. Okay, but we can do some. Now, when we look at, and we're going to do this in a few minutes, we're going to look at different platforms, and some of them are much better at the device and input output virtualization than others. And that's fine, right? We can pick and choose what we want to do. So, and all of this is handled again, used in software that's inside of the input output virtualization environment. So this enables a rich set of features and simplified management. So the key to effective input output virtualization is to minimize the amount of CPU utilized to perform these tasks. So wherever possible, we want to offload the functions away from the CPU to specialized software or specialized chips on our motherboard chipset that can do the input output. So how we handle that will be very, very important. Okay, so here's a system showing the host machine in the center, and it's going to virtualize all of these different devices. So like I asked you last week, what type of hard drive controller is in our machine, in our virtual machine, and without modifying this, this was just the default, right, from VMware. It used a SCSI hard drive controller. Now we're going to see when we use Hyper-V, it's going to use a default SATA controller. Now, does it matter what it does? I mean, it really doesn't matter as far as the way it's going to function. I mean, a hard drive is a hard drive to a virtual machine. But we know in our servers and in our desktops and in our laptops and in our, you know, handheld devices, none of those have any SCSI connectivity in them. I mean, SCSI has not been on the desktop in decades, probably 20, 30 years. So it's interesting that VMware, their default, right? We just said next through that part where it said the hardware configuration, and we're going to do the same thing today. And we'll notice that VMware will use SCSI hard drives. So for whatever reason, that's their default system, probably because that's what they started with, and that's what their code works best with. Okay, but we can do IDE controllers. We can do the ancient parallel ports, serial ports, floppy disks. So if we just do a default install, it may install a floppy disk, which is very archaic, or even the older, which is not rarely used, CD, DVD drive. And then away we go with the different components. So the device input output virtualization as well. So if we were to look at this table and we were to kind of say what technique is out there, is it full virtualization with binary translation, hardware assisted virtualization, or operating assisted virtualization or para-virtualization, we could look at this and at this chart, and we could see that the technique of binary translation is used for the full virtualization with binary. And then the guest modification is unmodified. Performance will be good, used by VMware, Microsoft Parallels. And then is the guest operating system hypervisor independent? And the answer is yes. Okay. So we can look at these things here, and it will give us some information. So if we have HAV, which is what everything is now, right? That's the default. Where there's my change my pointer back to. I'll do a laser pointer. There, that's better. With HAV, the technique is that it moves below the root mode, right? Unmodified, we don't have to modify anything, which gives us excellent compatibility. The performance is fair, but the current performance lags binary translation virtualization on various workloads, but will improve over time. And this has come very true. As the processors, the HAV code in the CPU has gotten better, over the generations of CPU design. This is actually, the performance has become very, very good. And this is used by VMware, Microsoft Parallel, everybody uses it. And the guest operating system is independent. Then if we use para-virtualization, use a technique called hypercalls, the guest operating system has to be modified or codified before it will run. So if we were to install a Zen server and then install Windows 10, there would be a step before we would do the install that we would have to modify the operating system so that it would install properly in Zen. And in some cases, that can actually give us better performance. And then it says used by VMware here. That's only because if we use the tools, okay? And then away we go. All right, so now that we've kind of talked our way through the history of the virtual environments and the kind of the evolution of VMware and the steps that they had to go through to really get this all cleaned up for us, let's look at why we would want to incorporate virtualization on your workstation. So this is not, we're not talking about server virtualization, but we're talking about on your desktop. So at home or at work on your workstation. So one, probably the biggest benefit to us as a technician or a support personnel is that we can have multiple operating systems. So we may work in a company that has both Windows 10, Windows 7, Windows 8. Maybe there's some, Fedora 31, CentOS 7, CentOS 8. Maybe we have some Macintosh machines, Apple devices. And if they call us up and we're, they say, Hey, Jordan, I have a question on how to change the settings for my graphics card. And they may say, and you say, okay, cool. Let me see if I can help you. Go ahead and click on start and type, and they say, well, I don't have a start. I'm using CentOS 8. And if you're not super familiar with CentOS 8, if you don't know it inside out, you're going to be kind of like, well, I'm going to have to come over and try to help you. I mean, I just can't do it from my memory. But what if you had CentOS 8 in a virtual environment, say in VMware Workstation on your computer that's running Windows 10? You could just fire that up, go into CentOS 8, go into the graphics settings, and you could walk through or talk to the user and explain, well, this is how you would make that change. This is what you need to do, right? So as far as support from the operating system support, it would be huge. Okay, another good use of workstation virtualization is it can help us consolidate our infrastructure environment. So it allows us to take some of these machines that may not be used all the time. Maybe it's only used, once or twice a year or once a quarter or something like that. And we have this machine over in the corner that, the accounting team, they only turn it on once a year to print a certain form that uses an older printer, that they have reams and reams of this tractor feed print for it. So that, like we said, businesses don't change things just to change things. They're going to update things when they can actually get a benefit out of it. So as long as the system's working, they may have that laying around, but we may say, why don't we just bring that into a virtual and configure it in a way that will, we can use, then we just turn it on, once or twice a year. Okay, that may be another reason for it with the virtualization for the infrastructure consolidation. And then the testing and disaster recovery. So this allows us, this testing piece, it allows us to stay ahead of any kind of changes we want to make. So just like we talked about last week with the Microsoft Solution Framework, right? The MSF, we want to be able to test and anticipate and try and figure out solutions without it affecting the actual system that we're using. So the ability to make this type of capability in our environment is really, really important for us, because a lot of times you'll be thinking about something in IT, you're supporting what's there, but you're always looking forward, right? You're like, well, I was reading this blog and they started talking about something I haven't heard of yet, but I'm interested. And then you start looking at it and you're like, that's really, I think we could really use that. Let me learn about it. Let me figure it out. So you may set up a test virtual environment for it, get it working, and then you can present it to, the decision makers to maybe incorporate it. So it will keep your business and keep you as an IT professional sharp and current and on the cutting edge of what's going on. All right. So the operating system support, we kind of talked about this, but it allows, like, you can run Windows software within your Mac, which is unheard of years and years ago, right? Years ago, it was like, you're one or the other. You can't be both. Well, today you can be both. So and that's because of virtualization software. So this can allow the end user to support a wide array of operating systems and various versions of legacy software. Okay, the infrastructure consolidation, since the full performance of today's computers is rarely needed full-time, one can pack many virtual machines into powerful host machine and balance the loads. So this can save significantly on hardware costs. And then the testing in disaster, something goes wrong, we can easily undo it by reverting back to a snapshot. So in our test environments, we can, say, before I make this change, let me save what that looks like. And I make a change. I say we're doing something new on our website. So we have it in a virtual environment. We're like, let's try this. Oh, the whole website just went down. Now, if we were in a production environment, if we were live, that would be disastrous. But in our test environment, it's like, okay, no problem. Let me just click undo, Control Z, and away we go. We're back in business. So that's a huge part of it. So what are some of the virtual options out there? And there are tons of these, right? There are new ones coming up all the time. The main ones are from VMware and from Windows, right? With the VMware's Workstation, and then Windows 10 with Hyper-V. And then Oracle's VirtualBox is very popular. There's Parallels for the Macintosh, and then many, many more. All right. So the first one we're going to look at, and delete this, and is Oracle's VirtualBox. This is the one, from my experience, most students, if they've done anything in a virtual environment, they have probably worked or looked at VirtualBox, right? Is that probably true of most of you at home or in other classes? You may have used VirtualBox. It's very simple. Yeah. Okay. So and very easy to use, and it's free, right? It's cheap, so there's no cost, and you can run almost all of the major operating systems: Windows, Mac, Linux, Solaris, whatever's out there. You can probably get a version of VirtualBox that will run on top of it. So if you have a Mac, you can download and install VirtualBox. If you have Linux, you can download and install VirtualBox. You have Windows, you can download and install VirtualBox. So it's available on all kinds of platforms. Now, one thing with VirtualBox is it also has it's very portable. So portability refers to where it can run on all kinds of hardware. So if you have a 32-bit, a 64-bit, whatever it is, it's probably going to run without any problems. Now, it does not require hardware virtualization. So the HAV is not required. However, to run a 64-bit operating system inside of a 64-bit processor, you must have HAV, which is fine for newer systems. The CPUs all have that enabled, but older systems, you may not be able to do that. Okay, you can install the tools, which in VirtualBox, they call them guest editions, that allows you to share folders between systems, seamless Windows, 3D virtualization, and so forth. And VirtualBox has a large amount of hardware that it will support. So if you install, say, a virtual on a Linux machine, it's probably going to be able to work no problem with your graphics card, your network card, your sound card, whatever's on there. If it runs in Linux, it's probably going to run in VirtualBox. Okay, and then VirtualBox has what's known as branched snapshots. So that allows us to go back in time with many snapshots. Now, the more snapshots you take, the more hard drive space you're using up. So you have to kind of be a little bit aware of that. But if you're doing some, let me try this, that worked, stop. Let me try this, that worked, stop. Let me try this, that failed, roll back. The taking of snapshots is a big deal. Okay, so here's what VirtualBox looks like. And And this is the VirtualBox manager or the administrative console for VirtualBox. And you can group your VirtualBoxes. Right here, we have our e-business virtual machines, our mobile platforms. So in this one, we actually have an Android virtual machine, which you can do, right? There's operating system ISOs that you can go download and install in VirtualBox. So if you're, let's say you're getting ready to study or sit for the CompTIA A+, and you're not super familiar with the Android because you only have an Apple phone, and you know Android is a big part of the A+ certification exam, you could go on and play with Android besides in simulators like Test Out or MindTap. You can actually get hands-on within VirtualBox. Chrome, which is a really simplified operating system that's out there on Chromebooks and Chromebooks, Chromeboxes, I should say, your Windows, your Linux, and so forth. So this allows, if this was on your desktop, and you can see some of them are actually running, right? Like the Windows 8 Enterprise and the Oracle Linux, and then Windows XP. Maybe they're supporting desktop users that have those operating systems, so they just keep it running in the background, and it doesn't have a lot of memory, right? Here's Windows 8. It only has 2 gigs of RAM, and the different systems may have even less than that. So Oracle Linux only has 1 gig of RAM. Windows XP only has 512 megs of RAM. So some of these older systems don't need a lot of juice, but we can support all of this in VirtualBox. Okay, so then the next one is VMware's Workstation. Now, Workstation, and we're going to actually install and build a VM in Workstation today on our Windows 10 machine in room 405, right? The Win10-CNET58 or -58 machine that you connect to with Guacamole. And VMware's Workstation, if you've never used it and you've only seen ESXi, for the last couple of weeks, it's going to have a similarity, right? There's a look and feel that is similar between VMware Workstation and VMware's ESXi with their vSphere. So this allows you to just about run any operating system. Now, VMware Workstation will run on top of, or you can install it on a Windows machine, and on a Macintosh machine, it's called VMware Fusion. So the name is not Workstation, it's called Fusion. Same thing, does functions about the same. The biggest difference between VMware and Oracle's VirtualBox is VMware is not free. You can download and install it, and you get a 30-day trial, which is what we're going to use today. But to use it, you have to buy a license that's around 100 to 150 bucks. Okay. Now, VMware is built, Workstation is built on all of the excellence and awards and everything that VMware has done since the beginning of virtualization. So it's extremely powerful and extremely robust. Now, as far as support for what operating system you want to run, it probably has the largest capability of running any operating system within it. Okay, so unlike, say, when we look at Hyper-V, Hyper-V is very limited. Hyper-V plays well with Windows operating systems, but not so much with Linux and others. Whereas VirtualBox is also very supportive of other operating systems, but VMware is probably the most capability. So you can create powerful virtual machines, and you can actually, with your virtual machines on, say, a tablet or say a Microsoft Surface, which is kind of in between a tablet and a laptop, you can do all kinds of things on your virtual machine that you could only do on the host machine. So let's say you have like an iPad or something, or an iPad Pro, you can run VMware's Fusion on there, and you can use the accelerometer and the pinch and scroll and all the different gestations and gyrations you can do with your tablet. You will actually function inside of your virtual machine. Okay, and it leverages the power of vSphere, which is what we're going to see today, where Workstation can integrate directly with our vSphere ESXi server, and it can also connect to the cloud. So VMware has a cloud service called vCloud Air, and that allows us to put our virtual machines, instead of on a server that we know about, like we know about our server, we can put it in the cloud with their vCloud Air services. Okay. Workstation is a great way to evaluate and test new operating systems in an isolated and secure environment. And it supports more than 200 operating systems, including when there's a preview of a new operating system. Like, so when Windows releases a new, or is about to release a new operating system, like when they're releasing Windows 10, the preview version, VMware is very quick at adapting to the new operating systems. So you can quickly get a look and feel of it without having to install it on actual hardware. All right. Now here's what VMware's Workstation Manager looks like. So here's Windows 8 inside of our Windows 10 Tech Preview inside of VMware. And you can see this has a whole slew of virtual machines installed on it. Servers, I have a bunch of desktop stuff, server stuff, Linux stuff, and then you can actually have VMware ESXi inside of VMware Workstation. So like when I'm working on some of these ESXi labs, if for whatever reason I can't connect to the Guacamole server, I have on my machine, I have I bought VMware Workstation, and it actually has I built a virtual of ESXi 7.1, so I can kind of look at what's in the newer version of the ESXi, so I can stay on top of that. Okay, so Workstation is very, very powerful. Now it supports the latest processor, whatever the latest and greatest is from Microsoft. VMware Workstation supports it. And this is an older slide, but from one version to another, they're up to, I think the current version is 16 or 17. The one we're going to use in lab is 15.2, which gives us a good look and feel, and it's compatible, or it works well with our environment. But the performance gets better every time you upgrade from one version to another. Now, with Workstation, you can create virtual machines with up to 16 virtual CPUs, 8 terabytes of hard drive, and 64 gigs of virtual memory. Now, that's a lot of processing, storage, and memory for a virtual machine. So this obviously means your Workstation has a big old amount of resources to do that. Okay, some of this CAD, SolidWorks, AutoCAD run perfectly within Workstation. So that's great. Optimized to support higher resolution displays and tablets. The Surface Pro capabilities like the accelerometer, gyroscope, compass, and ambient light sensor all will work within your virtual machine just as they would on your actual tablet. And here's the Windows 8 with the sensors enabled. So you can go into the settings and modify these capabilities within a virtual machine. So if you're now the host machine has to have this hardware. I mean, you can't enable it in a virtual that doesn't exist on the host. It doesn't work that way. I mean, you can't make it up or anything, but this will allow you to get some of those capabilities on your actual machine. Okay. VMware Workstation integrates directly to the cloud, where you can upload, run, and view virtual machines right from the Workstation's interface. You can drag and drop VMs between your PC and ESXi or another instance of Workstation. So we can, and this is one of the things we're going to do in today's lab, is we're going to build a virtual machine in Workstation, and then we're going to transfer it to our ESXi server. So it gives you a place where you can actually manage your virtual machines from your workstation. So this is really, really powerful. So let's say you're working on you're developing a new server, or you've been working on some desktop optimization stuff, and you have it in a virtual machine on your laptop. So you have VMware Workstation, and you're going to be out of town for a conference, but you still want to do the work on that. So you take your laptop, you get it all perfect. You get everything working the way you want it to. And then when you come back, you want to put that on your ESXi server. You could just literally just click on whatever the machine is, drag it down to your VMware cloud or your ESXi server, drop it, and then I'll say, do you want to upload it? Next, 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 and away you go. Okay. So the capabilities of working, all over the place and consolidating all your work in one environment is really optimized with VMware's Workstation. Okay. Now, with Workstation, you safeguard and protect your virtual machines and save valuable time by using snapshots and the clone feature. Duplicating Workstation's VM is easy. You just right click, clone, full clone or sync clone, and boom, it fires up a new virtual machine in a matter of seconds. So once you create one, clone, away you go. All right. So here's the snapshot manager that shows what you've done. So here is our original or our baseline. Then we install Chrome 37. Then we install Project X. Then we do the build. Now we're here. Well, we may want to say, well, I want to take a snapshot here, and then I'm going to go this route. Then I'm going to go back to the snapshot. I'm going to try the same thing with Mozilla Firefox, make sure it works. I'm going to do the same thing with Internet Explorer. So testing it, you don't want to develop an app that only works with one browser, right? That can be kind of problematic. So this will allow us to make sure it works all the way through. Very important, right? So that's Workstation, VMware's Workstation. The next one we're going to talk about is Hyper-V, which is in our Workstation version is known as Client Hyper-V. So Client Hyper-V is integrated in our operating system. So I'm gonna stop this share, and I'm gonna share my other screen because I'm gonna show you what this looks like. So I'm gonna share this screen, and if I just click on Start and type Hyper-V, it gives me the option here in Control Panel to turn Windows features on or off, and I can come in here and I can select Hyper-V, and that will install Hyper-V on my machine. Now, one thing I want to warn you is if you have VMware Workstation and you have Hyper-V running, they don't play well together. Or VirtualBox and VMware and Hyper-V. If you have more than one of them, you can really end up with some problematic outcomes. So you really want to be careful to make sure that if you have Hyper-V, you only are using Hyper-V at that time. Now we can do some boot manager stuff to boot into an environment that supports Hyper-V and then reboot into another environment that is better suited for VMware Workstation or VirtualBox or whatever. But they don't play nicely at the same time. No, excuse me. All right. So Hyper-V is built into Windows 8 and Windows 10, but you have to have the professional or enterprise education version for it to work, for it to be available. If you have the home version, it's not in there. All right. So, and it's built on the same technology that is in Windows Server Hyper-V. So if we use Hyper-V in our workstations, and then we start working on a server that has Hyper-V, it's going to have very similar capabilities. So when we get to Hyper-V, if that's the first time you've seen it, it looks and feels like a Microsoft application, but it's totally different than ESXi. So you may have to relearn where some of that stuff is. But if you have Hyper-V at home on your Windows 10 machine, then it looks and feels the same. Okay, so it virtualizes hardware to provide an environment in which you can run multiple operating systems at the same time. It enables you to create and manage virtual machines and their resources. So here's the Hyper-V manager, where we have our host machine, right, which is the computer name here, and then our virtual machines here. And then we can go in and we can, turn them on, turn them off, and do all the settings and all the stuff that we do. All right. Now, when it comes to the Macintosh, the free versions for the Macintosh are really, I guess you could say Boot Camp is a form of this. It's not really a virtual environment. It's more of a dual boot environment. That's free. That comes built into your Mac. And then the only other one that's free is VirtualBox. VMware's Fusion, Parallels, and all these other ones, you have to actually pay for. So, that's just kind of the cost of doing business in a Mac environment. Whereas on Windows, we can do Oracle's VirtualBox for free, and we can do Hyper-V for free. But if we want to do anything else, we have to pay for it as well. Okay, so Parallels allows you to run Windows on your Mac. So you can move your PC to your Mac very easily. So some people, they're maybe a little intimidated. Oh, I'm not familiar with the Macintosh. I've only used Windows. Well, this may be an option for them. Well, let's get them a new Mac, say a new iMac, install Parallels, put their old system in Parallels so that they can use it and then learn the Mac as they need it. It's not going to slow them down. It can run Windows extremely well in your Parallels in the Mac. And then that's the target audience. They're not really aiming at Linux installs or capabilities there. The other thing that you can do with Parallels is you can actually, in your dock, right, which is that bar normally at the bottom of your Macintosh, you can put your Windows apps there. So let's say we have an application that only runs in Windows, like Microsoft Office Access, right? The database application in Office is known as Access. It only runs on Windows. There is no version of it for the Macintosh. But say we have a big database in there and our users need to manage it or update it, we can just put in their Docker or in their dock an icon, drag an icon in there, and they double click it and it will automatically open in Parallels on their Macintosh. And it's seamless, right? And it looks like it's part of your Mac. It doesn't look like, oh, I'm in, this, obviously this looks, when you run Windows 8, or like when we launch ESXi, you can tell you're in a different operating system because it looks totally different. There's no, blending of one OS with the other. With Parallels, it's very blended. I mean, they look like they're built together. So very, very powerful. Okay, so here's Windows 7, Windows 8, all within my Macintosh machine, and it runs seamlessly. In fact, you can get some optimizations on here where some of these bars just disappear, and it just looks like all this is just on my desktop as an app. So you just double click it and away you go. All right, so that's what I wanted to cover as far as the workstation virtualization. Are there any questions or comments on any of this so far?
No, but I didn't know you can do parallel on Macintosh. It's kind of cool.
Yeah, no, you can. Louis, I know you use a Macintosh. Have you used Parallels?
Yeah, I use Parallels. I have Boot Camp running, and so I use Parallels to quickly access my Windows operating system. So if I want to play like simple games, I just use Boot Camp. But if I want to just access a Word file or access or just see something how it works on the Windows, I just quickly open Parallels.
Yeah, yeah. So I mean, it's pretty seamless. Have you used Fusion at all on your Mac?
I actually haven't. I just heard about it as you said it. I probably should try it out later.
Okay, yeah, I've used Fusion and Oracle's VirtualBox on my Mac, and then Parallels. They all do about the same thing. It's just, like anything, you kind of get used to one and get comfortable with it. All right, so this brings up a concept or a discussion. Can you run, I mean, obviously this slide shows we're running Windows on a Macintosh. Can you run Apple OS on a Windows machine? Anybody? The answer is yes, but you're not supposed to. Yeah, technically, ... you can run Apple on a Windows environment. However, as we know, Apple builds the hardware and the software for their machines, right? Apple designs the hardware and they also design the operating system. So they have designed their operating system to only work with the hardware that's built into an Apple hardware machine. And what they've done, they've actually put a chip, a security chip in the code of the motherboard so that when Apple installs, it looks for that code. And if it's there, it will install. If it's not, it won't. So if you were just to, take your Apple DVD of, whatever OS 10.4 or 5, say you have an older version laying around, and you make an ISO and then you install VirtualBox and then connect the ISO and then boot it up, it will get a certain point that will just error out. You'll get an error. And as Louis said, there are workarounds to that where you can actually do what they call it a patch. It's really a crack of the operating system or of the VirtualBox, and then it will actually install the Apple OS in there. Now, besides just the hardware complications or variations on there, there's also the software license. So when you look at the software license for Apple, it explicitly states that this is designed to run only on Apple hardware. So if you put it on, say, a Dell machine or, you know, a PC, you're in violation of their license agreement, which, you know, is no good. So you don't want to do that. All right, but it can be done. I'm not saying you can't do it. It's just it's harder to do. All right, so I'm gonna pause this right here, and what I'm going to do is, let me stop the share, and I'm going to come in here, and I'm actually going to publish quiz 1, and quiz 1 will open at 10 o'clock. So let's take a 5-minute break, and then if you want to jump on to quiz 1, feel free to do that. And then around, I'll give you, I don't know, maybe half an hour, 45 minutes to take quiz 1. And if you don't finish it, just leave it open, and you can work on it after we get started on the lab. But I want to jump into the lab a little bit earlier today, probably around, like I said, 10:45 or so. So I'll give you about 45 minutes to get on quiz 1. It shouldn't take long. I mean, there's 25 questions. They're open book, open note, open, you know, whatever you want to open. And then you can go through and do quiz 1. And then I'm going to jump right into lab. Now, there's other slides on the PowerPoint for remote management, local and remote management. So I'm going to leave that for you to read those on your own. And, you know, you may have to refer to some of that in the quiz too. So let's take a short break until 10 o'clock. And then the quiz will start at, it'll open right at 10 o'clock. So in about 3 minutes. And then I want you to start quiz 1. All right. So go ahead and take a break. Then we'll come back, and we'll let that go for a little while, maybe, like I said, 45 minutes. And then we'll start the lab at around 10:45. All right. So I'm going to pause the recording.